it's really simple. So that's about it. Now let's say we wanted to have more than one option, and let's say we wanted to lay them vertically. So if you want to add multiple rows, you can go ahead and use something known as a vertical box. So if I right click on this, type in wrap with and use a vertical box, you can go ahead and get this. Now the vertical box will automatically use the same anchor as we used for the child, but nonetheless, it's just something which you can change. Change the size Y to something big maybe, and press Ctrl D to duplicate this button. Now over here I can type in exit, let's say, and again on clicked we can change that. So play button 1 is not appropriate, we'll change that to exit button. So exit button, and on clicked we can go ahead and execute console command, and we can type in exit. So that should be good to go, and you'll notice one thing, it's just taking up a fixed amount of space and it's not actually filling it properly. So if you want to do that, you can select both of these and select fill. Now let's say you wanted your play button to occupy more amount of space than exit. So you can increase this text box which is available to you. So if I hit 2 and the exit button has 1 on this option, basically they are occupying space in the ratio 2:1. That's basically what it means. So you don't want your players to exit obviously, so you'd make the play button bigger. So this is how you do it. Now if I press play, now the same logic is copied over. The reason why the sound is playing even for the exit button is because we copied over the code. So that's why. So all the sound effects as well is copied. So as you can see, press sound and hover sound are actually the same in both of these. Now if I press play, if I press exit, we are going to quit the game. If I press play, we load into this level. So that's pretty cool. So that's about it for this part. Now it's time we start talking about another feature which Blueprint offers. That is Blueprint function libraries. Now let's say you wanted to have some functions which might be used in multiple places but are not relative to a certain object. So in that case you would use a Blueprint function library. So let me actually show you guys an example. So head into Blueprints, and or maybe we could create another folder. Let's call this one function libraries. Open it up, and over here right click, head into Blueprints and select Blueprint function library, and we can call this one my or our Blueprint function library. Now inside here you would notice that we actually have functions, options to write functions. So for example, let's say we have something generic. So for example, let's say we have a vector, and let's say we wanted to normalize it. Now obviously there is a normalize function already, but I'm just taking an example. Now normalizing a vector is a general operation. It's not relative to any object. So we can type in normalize. And for the input, obviously we are going to take in a vector. So take in a vector, and we can type this one in maybe. And now once we have the vector, we are going to first of all get the magnitude of this vector. The way you get magnitude of a vector in Blueprint is by typing in vector length. So get vector length. Now this is the magnitude of the vector. So we can divide this vector by the magnitude. So that is going to normalize the vector for us. And once we actually do that, we can go ahead and return it. So this is going to be the return value, and obviously we'll make it a pure function. Now let's just call this one normalize underscore hours, because I think there is another function called normalize, so just so that it's understandable for us. Now head back into any one of your blueprints, let's say our level blueprint, And over here, if we just type in normalize, so we already had a normalize function, but I just took the example, underscore ours, you see we actually get our function, and this is not relative to any object, so you can call this pretty much everywhere you wish. So this is basically your blueprint function library. You just go on creating functions. So once that's all settled, now what if you wanted to use some code or some assets created by somebody else? There is actually a huge marketplace called the Unreal Marketplace, and you can access it through the Epic Games Launcher. So if I head into my Epic Games Launcher, head into Marketplace under the Unreal Engine section, you would see that you get a massive library of assets, and there are a bunch of free ones as well. Like I really mean a lot of free assets. So what if you wanted to use them? So that is where using plugins and other content packs comes in handy. So how you do it is really simple actually. So for example, I know one which is very handy. It's called low entry, I believe. Oops, low entry. So I actually have it in my library. So it's by this publisher actually. So low entry standard library. This is the one which I'm using. This is really useful. So once you search it up, and you can look it up in the marketplace, and there are many forums on Reddit and stuff talking about which plugins are good and stuff. So you can go ahead and install it according to your needs. So let's say I wanted some weapon models for prototyping. You could just type in weapon and you're going to get weapon packs. The way you install it is by clicking on this install to engine button. I've already done that, so that's why it shows that I can't. Now over here in my plugins panel, now I should be able to access it over here under installed, or if you just search it up, you would be able to find it and you can enable it. So low entry extended standard library, and I need to restart the editor. So let me go ahead and do that. Now that it's done, I can go ahead and use the content in the plugin. Now, how do I know what content is there? There will actually be a documentation and source code and stuff available. So you could just look it up. So there will be a place where the documentation is given. So you have a preview over here. Then you also have access to the source code and a bunch of stuff. You could also take a look at this over here. So maybe let's say we wanted to use some function here. So for example, I type in is debug build. Let's say I wanted to see if I am currently in a debug build. So I can type in is debug build. Whoops, debug build. And as you can see, I can use the function. Now this was a plugin which has to be installed to the engine. However, we will also look at other types of plugins, such as, let's say I type in weapon, for example, I needed a weapon pack. So I actually have some in the library. You could find a free one, so you can head under free and you can look for it. But again, now in my library, I actually have some weapon packs. If I want to install those, it's actually really simple. So FPS weapons bundle, this is one thing which I have. So I can go ahead and add this to a project, and it does say none of my projects are compatible, but plugins like these, actually it doesn't really matter if you're using a later version than what is supported. As long as you're using a later version than that, it should be totally good to go. So click on show all projects and you can go ahead and select this, and you can change the version to the latest available one, and you can go ahead and add it. Now, just another thing, in case you don't have a plugin of this sort, so the one which we saw last time. So let's search for low entry once again. So let's say we have a plugin of this sort, which you install to the engine, but you actually don't have the appropriate version. So the way you'd actually go about upgrading your version is actually really simple. People haven't made any tutorials on this. I don't see any forum or anything talking about that either. So basically you just come into your Unreal Engine installation directory. So I go to program files, Unreal Engine. This is where I have it. And over here under engine, plugins, and the marketplace ones will be in the marketplace. And for example, I go to low entry extended standard library. I can right click on this U plugin file and I can actually open it with any text editor, or I can open it with something like VS Code. So I'll open it with Visual Studio. Inside the U plugin file, you should see something a little like this. So you don't have to worry about any of these things. The only thing is the engine version. Let's say it was there for 4.27 and you're using 5. And if you want to make it compatible and let's say you're getting build errors, you could just go ahead and change 4.27 to 5.0.0. So let's say it was 4.27.0 by default. So you can go ahead and change it to 5.0.0. Whoops, 5.0.0. So stuff like that. Alright, so that's about it. There isn't really that much depth to plugins. I mean, I will talk about creating plugins and stuff, integrating third-party libraries a bit later on in the advanced part of this course. But now let's go ahead and actually talk about a recently released tool, and which is quite handy in my opinion, and those are the modeling tools. First of all, in your plugins section, make sure your plugin is enabled. So make sure modeling tools editor mode plugin is enabled. And if you don't want to separately drag your model in the level and edit it, then you can press this as well. And now if you check your content browser, make sure you have some sort of a 3D model. Make sure you have some sort of a static mesh. So you can import that from your 3D software. So I just got one in from the engine content. So what I did was basically, actually I'll just go ahead and delete that and redo it. So delete that and delete this folder as well. Save everything. Now I just search for SM underscore. Usually it's a convention to name it SM underscore for static mesh. Under content, I just went ahead and created a new folder. So new folder, and I called it models. Open it up and just paste it in, just using the one from the engine content. Now you can drag it in the level and start editing it by heading into this tab right here and heading into modeling. So we have a bunch of options. The first few are for creating objects, but some of the useful ones are, for example, moving the pivot. So let's say you didn't want this to rotate along the center. You can go ahead and type pivot and you can move this point over here. Now if I rotate it, it's going to rotate along this point. And these changes are actually applied to this. So even if I just drag in another ball, these changes will be applied to that. So just be careful while using them. Of course, you can undo them at any point. So just save that. And sculpt is basically to deform the shape. So something like this. And again, you can use shift. The same principle works over here as well as we did with the landscape editing. So stuff like that. Then desculpt does a similar thing, just works a little bit differently. So I can just drag it like this. I'm not sure what I did there, but yeah. So I'm not really here to talk about the tools in detail, but just to give you an overview of how to actually use it. So you could experiment around with all of these. So if you type in accept, so now we have this shape. Obviously it just messed up with the UV map and the materials and stuff. But anyways, that was not our point. Now a couple of useful things. First of all, creating shapes. So if I just type in stair over here, and if I head into this and I can actually make it a curved staircase, I can actually increase the number of stairs. I can decrease the step height. So I can increase the curve angle, for example. Then I can decrease the step height. So I can make it something like 10. Maybe place that and type in complete. Now if I go ahead and press play, you would be able to see that I can actually use my stairs. So that works well. So stuff like that. And now shapes are pretty obvious. Obviously, just create a box, do stuff with that. And now you might be wondering where these are stored. Over here, just check what is selected under this, under the new asset location. If it is selected to global, in your content folder there should be a underscore generated folder. In my case, it was set to world relative. So wherever you have your map, over here you should see a underscore generated folder. And if you open it up, you should be able to see your static meshes. So for example, we have this stair which we just created and we can drag this in. So this is going to come in really handy for many people, in my opinion. Now, not only that, it provides us with several other cool features. I'll just showcase one of them actually. So if you head into your modeling tools once again, so I'll just close it and open it up again. So I'll open up the modeling tools, and if I type in poly extrude, you can actually draw a shape. So if I just click somewhere, drag a point, do something like this, and if I join them, now I would be able to create something like this. So let's say I wanted to create a castle wall or something, you could do that. And the good part about this is UV map by default. You don't have to actually UV map it. The UVs are pretty good. So you can directly go ahead and apply a texture and it is going to look decent. Generally, if you create a weird shape like this in a 3D modeling software, you separately have to go through the effort of UV mapping it so that the textures don't look distorted. But in this case, you are good to go. So that's about it for the modeling tools. So you can mess around with those. These are really, specific to what you're doing. So according to what you would need, you would use the appropriate tools, but it is there. Now even over here, you can change the pivot point, let's say for example. So I'll just show you guys once again. So modeling, if I select pivot, and if I move this over and press accept, you would see that the pivot point moved over there. So that's about it. So let's move on to the next part. So what I'm going to be talking about next is kind of the basics of what we did till now. So basically we worked with these models over here. Basically these are called static meshes. So any and all 3D models which you get in the engine without any sort of animations or anything, those will generally be static meshes. Any mesh with some sort of animation is going to be a skeletal mesh basically. So stuff like characters, gun models, and those are going to be your skeletal meshes. Anything which simulate physics or which does not have animations. So for example, this staircase, maybe a weapon model in a pickup blueprint, stuff like that are going to be static meshes. So they are recognized by a light blue color in the content browser. So if I head into models, you see it has a light blue color coding, and this indicates that it's a static mesh. Now we will dive into skeletal meshes a little more in depth later on, but for now I'll just head into static meshes. There are a couple of things which I would like to cover. First one is enabling nanite. Now if I head into wireframe mode, so now I can actually see all of the vertices in space. Now say I have many of those spheres, and in this case I have more than 6,000, so 6,480. So your first question over here is, how's the performance still this great? That is thanks to nanite. So if you right click on your model and enable nanite over here, if you right click and click on enable, you will enable nanite. Now if I go ahead and disable this, you would see that the performance dips immediately. So that's one thing about nanite. So as you can see, it's really not playable at this point. Now obviously this is highly unrealistic, and moreover it will depend more on your computer as well. So if I go ahead and enable nanite now, and if I press play, as you can see, even with so many spheres right in front of me, it's absolutely not affecting performance. Now we are not here to talk about the actual technology involved in nanite, so that's the reason I'm not telling anything else. But this is basically it. Currently in 5.0.3 there are a few limitations. For example, let's say you wanted to use this on a tree, you probably cannot, because trees contain leaves and leaves used masked materials, and those are not yet supported on nanite, but they will be supported in 5.1. So very soon you would be able to use them. So that's about it. There are a few material features which you can't use, and we will talk about materials. So stuff like dithering and stuff, you will have to just disable those nodes if you want to use nanite. But for most objects, so stuff like walls, or maybe if you have an insane level, something like this, nanite is going to come in handy. So that's about nanite. By now, one thing that you would have probably noticed is that any and all objects in this scene actually have some sort of a material on them. So for example, this has some neon blue texture on it and it seems to be glowing, and this box right here has some sort of checkerboard, and same with the ground. So what's up with that? So basically those are materials, and that's what gives the color and all the other roughness related properties of a given surface. Now let's actually go about seeing how to create a material and apply it on objects. So let's just use a cube for example in order to demonstrate using materials. So let me just grab in a cube and I'll just place it in the scene. Now this has a material, basic shape material. You can actually explore this by clicking on this search icon over here. So you'll actually go to the directory where the material is stored. But in our case, let's create a new folder called materials. And let's go ahead and open it up. Right click and create a new material, or you can head into materials and create a new material here. Now the most important ones are just materials and material instances. The rest are just stuff which you might need in specific circumstances. So we'll take a look at material and let's call this one our material. Now applying a material on a surface is actually really simple. Now we aren't going to be dealing with multiple materials on a single object in this part of the course. We will try to deal with it later on, but for now we won't be doing anything. So by default you get this checker material, so I'll just drag this in, and you can, in order to apply it, you just drag it basically on the surface. That's how you do it. Or if you want to apply it to a static mesh in general, so let's say I wanted all of the okay, whatever this object is. So let's say I wanted all of this object to have our material. So what I do is I'd head into the static mesh, and over here I'm going to select our material. So let me go back. So all content materials, our material, you can select that and you can click on this arrow icon which will use our material. So now it's actually using our material. So we haven't seen any change because we don't have anything set up in the material. But the way you actually start working with this is by using these nodes. So this pin right here is, as the name suggests, the base color. Now how do you define a base color? So the most basic node over here is going to be a constant. So whoops, I press C on the keyboard. I'm supposed to press 1 on the keyboard and left click. And you see you get this node here which allows you to enter a value. Now generally you would enter a value between 0 and 1, but in some cases you would enter higher and lower values. So in this case, if I just plug this in the base color, and you can see it's compatible, so you'd see that our material is fully black. Now it's just a fully black material. What if I increase this a bit? Now save that again. As you can see, it became a lighter shade of gray. So 1 is going to be white. So this is basically a gradient. 0 is black and 1 is white. What if you wanted to give a color? So you'd hold 3 on your keyboard and left click. Then you'd get something known as a constant 3 vector. This is basically your R, G and B values. So red, green and blue. So you can go ahead, if you wanted red, you could do 1 on red. And as you can see, you get a red color material and it's applied to all the objects which are using our material. So that's about it for base color. Now if you want to bring in any textures, I recommend this website called CC0 Textures. So open it up. Now it's renamed to Ambient CG. Keep forgetting about that. So if you just head in and you can just grab in any texture. So I'll just grab in the lowest resolution one. So I can open it up in my folder over there. And over here I'll just drag it into images for now. I just have it set up like this. So I'm just going to extract it. And over here you see you get a bunch of textures. If you want to import it in the engine, it's really simple actually to import any asset, be it textures, models or whatever. So we'll create a new folder and we'll import it. So textures, open it up, and if I go ahead and drag this, for example, so I can just select all of these and I can go ahead and drag this in my content browser, and we can go ahead and save it. Now if I want to apply this texture to this material, now first of all we'll see which one is the base color. Sometimes these textures are labeled as albedo, but albedo is basically a base color without any sort of shadow related information. That's basically what it means, without any other sort of detailing. It's just the raw color. So if I drag this in the base color, I can do that. Now you could do this as well, totally fine. So this is how you bring in a texture. Now if I go ahead and look into my level, you see we have this wood texture on our little wall here. Now what if I wanted to tile this texture a little better? Now let's say I wanted to make this bigger or smaller. You'd use something known as a texture coordinate. So you type in text coord and you're gonna see texture coordinate. Plug that into the UVs. And now let's say I press 0.1, your texture will now be scaled 10 times. U and V are basically like your X and Y, to be very vague. Now we zoomed in way too much, so let's make 2 now. So now you see it's going to be more tiled. So now if you would see, you would have a more tiled material. So if I make this 3 for example, and if I go ahead and save this, you'd see that it'll be even more tiled. So I can make this 3.5, I can increase the value and it's going to be more tiled. So I can click apply, save, and I should be able to see there are more number of bricks. Now I'll just set this to 1 once again and save that, and as you can see it's applied to our level. Now this may be fine, but what if you wanted more details? Let's say you wanted to make this very glossy. So in that case you can use the roughness node. Now the roughness is basically a 0 to 1 value, so you can again use a constant if you want. So 0 is going to be fully reflective. Now you could use the specular channel as well, but most of the times you'll only use roughness. It's very rare that you will actually mess with the specular channel. So now if I go ahead and apply this, you'd see that it's very glossy. And if that's not really that clear, drag in a point light, just move this, and as you can see it's reflecting everything over there. You see the little point over there, so that's showing roughness 0. Now if I change this to 1 for example, and if I hit save, you'd see that it's not reflecting the light at all. So that's the use of the roughness channel. Now obviously this is some sort of a wood floor texture, so obviously it will be depending on the grains of what's there over there. So how you would set it up is by using a roughness map. Now generally in websites such as CC0 or ambient CG now as it's called, you would get something known as a roughness map. Basically the brighter parts of the image are where the light is reflected more. The darker parts of the image are where light is not reflected. So let's say there is a fully black area here, so that's where all the light is going to be reflected. So I might have told it the other way around. Basically the more bright the color, the more the roughness. Now if I drag this in, use this in the roughness channel, as you can see this gives us a little more definition. Now as you can see at the borders over there, you can clearly see that the roughness map is doing something. So this is about roughness. Similarly, normal is basically your depth. So as you can see, this texture, although it has a bit of roughness, it looks completely flat. Now if I go ahead and add in the normal map, so if I just snap this to the left and bring in my Unreal editor on the right, And if I go ahead and apply my normal map here, and if I hit apply, as you can see, you'd see a little bit of a depth over there. Now, if you can't really see it, that's probably because this is pretty subtle. So you can use something known as a multiply. Basically, it's just going to multiply the value of each pixel in this texture. So multiply this, you can use a constant, or you can set the value over here itself in the multiply node. So if I type in 100, let's say, for example, so now you would be able to see a little bit of the depth over there. But since this sort of a texture isn't really containing much of depth, so you won't really see it. There are other ways to increase the depth of a normal map, but that's not the point of this tutorial. So basically, normal map is for your depth. If you're into PBR rendering, you'll probably already know all this stuff. Ambient occlusion is basically like your depth in your crevices and stuff. It's kind of hard to explain it. There's actually a comment here. So simulate the self-shadowing that happens within crevices of a surface. Basically, that's what ambient occlusion is. So in stuff like trees and rocks, ambient occlusion is something which would play a major role. In this sort of a texture, it's really not going to do much. So this is about the basics of materials. Now, obviously, this is completely wrong because we only have a texture coordinate for that one texture. So make sure you plug everything in. So just plug everything in. Now if you go ahead and apply and save that, now you'd be able to see that it's applied properly. This had a subtle effect from the start itself, so that's the reason you couldn't really see anything wrong with it. So we created a basic material here. Now for any of these, you can actually use your constants, but most of the time, except base color, you won't be using constants, you'll be using textures. Now that's the very basics of materials. There are a lot you can do. Let's say you wanted to make this thing glow. So let me just remove all of this stuff. Let's say I just wanted a glowing neon green color. So let me just get a constant pre-vector. So the same right click search menu exists in the material editor as well. Drag that in the base color. And what you want to do is first you can grab in a constant and maybe let's say you have 10. This has to be a value greater than 1. So let's say I have 2 for example. So now you'd see that it's completely glowing white in color. Now if you wanted it to glow in this color itself, what you'd do is you'd actually get this and you'd multiply this by 2. So you'd multiply this by 2. Now if I go ahead and press save, you see it's glowing in a sort of green color. So this is basically called an emissive material because it emits light and it's pretty cool to look at. By adjusting the value you multiply it with, you adjust the intensity. Now one problem which you might have noticed here is every time we want to change a value, so for example we want to make this less bright, let's say 1.5. Now every time we have to apply and save this. What if we could dynamically change this? That's where material instances come in. It's basically like your derived class in your C++ inheritance. But to put that in short, basically you create another asset known as a material instance, which is subordinate to this material, and you can edit all the parameters in it. So I can right click on our material and create the material instance, and let's just keep it as the engine has suggested. Now instead of applying our material, we'll apply our material instance. Nothing has changed obviously. However, if I head into our material instance, now I can change the parameters over here. The first thing you might notice is there is nothing to change. So how do you do that? Basically, you'd have to head in here, right click and convert it to a parameter. So any constant or any texture which you convert to a parameter will be a value which you can change. So this is going to be called brightness, let's say. Brightness. and this one is going to be called color. So right click, convert to parameter and call this one color. Now apply and save it. Now if I open up my instance, you'd see that you get two parameters and now I can edit them. So now if I press 2, you see the changes are live. So 0 works, 1, 2, 0.3. So I can adjust my values just like this. And I can change the color as well. And it's updating dynamically. So for the most part, you'll be using material instances for this purpose itself. So these were the basics of materials. Now you could tinker around a bit, look into the documentation and create something yourself. Now we haven't talked too much about the other type of mesh, that is the skeletal mesh. So let's talk about that now. Now if I go ahead and press play actually, you'd see that we have a character over here which is moving around. Now the animations aren't actually complete. If you were to notice, he's just sliding around, he's not actually doing anything. Now how do you define the logic where, if you're moving above a certain speed, maybe let's say you start moving, you want to play an animation. How do you define that? So that is where you use an animation blueprint. And that is what I was searching at the start of this course when we actually did the character. So head into your character. Over here, one thing that you would notice is if I just head into mesh and if I just click on the search icon on the animation blueprint, it actually takes us to a folder inside the engine directory where there is an animation blueprint which actually does something over here. So this is how the animations are actually controlled, and we'll create one from scratch. We can reuse these animations, no problem. So head into your content folder, not the engine, so content, and for now we can just head into our models folder, and over here let's assume we had our character here, so let's call that tutorial character, because I guess that's what it was called, tutorial TPP I guess. I'll just open it up, right click, create under animation, create an animation blueprint and select the skeleton. Now I'm assuming you have a little bit of knowledge of what's a skeleton, what are bones and stuff. So at least that much would be required if you want to understand this. Basically know that each joint which you have, each point which can hinge basically is going to be your bone. So if I'm not clear about that, if I head into the actual skeletal mesh, so if I head into this one, so I'm not sure what it's called, and this one let's leave it at new animBP. So let's TPP I guess. So this is the skeletal mesh. Now if I were to just click on this and if I head into the skeleton view, you'd see, for example, this is going to be your index. So if I rotate it, you can see that we can actually control it. Index 2 is going to be the further part of the finger. Stuff like that. I'm not actually applying these changes, so that's totally okay. And for example, if I take the pelvis, I can go ahead and rotate the entire thing because that's the root, that's the reason it's happening. If I take spine, it's gonna rotate the back. Stuff like that. Let's say you wanted to rotate it a little something like this. So you could make him bend forward, stuff like that. So this is a skeletal mesh, and output pose over here in the anim graph, as soon as you open the animation blueprint, this is what determines what pose you're in. By default, it'll just take a T pose or whatever pose it was in when you imported the model. So let's apply our animation blueprint to our character. So head into your character, select the mesh, and for the animation blueprint, let's select new animBP or whatever that was called. So new anim blueprint. So as you can see, we are stuck in a T pose right now. And let's start applying animations. Now, in order to add an animation, the most basic way you could do it is you can simply drag in this animation and you can play it. So this is going to be the idle animation. And these are animations which the engine has provided. So I haven't really done anything here. So If you have your own character, you would have your own animations. But as you can see, there is really no logic that you can define over here. So the way you do that is by, first of all, we can start by creating a state machine. This is the most basic thing you can do in an anim blueprint. So basically you can use your variables over here to determine logic on how to change between animations. Let me show you with an example. So we'll just leave it at new state machine for now, or we can call this one walk run, maybe idle walk run, let's say. Just name it appropriately. And now if I compile, I'll be in a T pose again. Now entry is where you'd start. So obviously if nothing's really happening, you'd want to idle. So head into tutorial idle. If you were to notice, it just outputs the animation pose. This is something like your return node basically. Head back into your idle walk run state machine. Now if I compile, as you would see, it's playing the idle animation, and if I press play, actually this is going to work. Now we want another state, so right click, add state, and this one is going to be called walk/run. Now this is a shortcut way to do it, like I'm not doing a separate walk and run phase. I will do a separate walk and run state after I do this. So we want to be able to transition from idle to walk run, so drag in an arrow. And when we stop, we actually want to be able to go back as well. And I will show you what I mean by that. Now if I head into walk run, and if I drag this animation, you would see that he's not actually heading into walk run. So what you can do is you can just set this to true, for example, and you would see that he will be in this walk run state. So what this basically is if this boolean is true, the character will be able to transition from this animation to this basically. So how do you do that? We can actually set up some logic here. So we can say is moving, for example. This is not how you do it. I'm just showing you guys the basics. So if he is moving, we want to transition to the run phase. So idle walk run, we have that. Now in the event graph, we'll actually set up the logic to get is moving, because remember we only have the variable, but we're not actually setting the value. So every time the animation updates, so that's going to be every frame. What we can do is we can try get pawn owner. Basically that's going to be our character reference, and we can cast it to our I don't know what it was called, BP character, I guess. Cast it to that. Don't do a cast on update actually. You can actually do it on, I guess it's called start. There's an equivalent of begin play actually. Event blueprint begin play. So on this node you can actually cast it, and you can store a reference and use that. Don't cast to it every frame, it's not efficient. So you can promote that to a variable and call this one character reference. So character reference. And once we have that stored, what we can do is we can use that if this is valid, of course. So convert to validated get. If our character reference is valid, what we'll do is we will get the speed. So how you get the speed is by getting the velocity. So velocity, get velocity, and we are going to get the vector length. And if this vector length is greater than 0, it means we are moving. So now if I compile, you see he's idle. But now if I press play, if I start moving, you see the animation triggers. But now he's not going back. And that is where the transition comes in. We have set up the logic to go from idle to walk run, but the engine doesn't know when to come back. So a very simple thing you can do is put this back. And if he is not moving, so you can type in an exclamation. So if he is not moving, then we can go ahead and transition back. Now if I press play, as you can see, it's working just fine. Now there are only two animations here, but what if you wanted to blend between them? What if you wanted a walk phase, let's say? So the way you do it is by using a blend space. So what a blend space is basically transitioning between two animations. And I'll just show that. I'm not really going to talk too much in depth about animations and stuff. But I guess you guys kind of get the basic idea. Let's say you had like a jumping animation. So what you do is you'd have another boolean for the jump state. And in this state machine here, you'd create a new state and call this one jumping. And then you'd transition from this and you would go back, stuff like that. That's basically how you do it. And now if we wanted to set up our blend space, as I told you guys, so head into your models, tutorial TPP, and let's just right click animation and let's create a blend space. So now we can select a skeleton and we'll call this one walk run, for example. So walk run. If you have a separate walking animation, you can inject it in, but for now we won't. Now in the axis settings here, this is what you will actually be using. So your vertical axis is like your speed, basically. I mean, it's a convention. You can interchangeably use this, but you can use the vertical axis as speed. So basically you see the value 0 to 100, so that's what it is. So we can type in speed because we can use this name later on. And for the horizontal axis, we can call this one direction. And it's going to be from minus 180 to plus 180. Over here for speed, we can go 0 to whatever maximum speed. By default it's 600, so we'll go with that. And we don't have sideways animations. Otherwise, on the left here, you can place your sideways animations. I'll just show you with these ones. So obviously when your speed and direction is 0, you would be idling. And walk forward is going to be over here. Now if I hold down shift and if I walk through this, so whoops, so I must just leave that over there. So at 0 and 0 and hold control, actually hold control, and if you would notice, you're transitioning between the animations. So if I play, as you see, now if you're walking slowly, so let's say I leave it at here. So when my speed is 373 and my direction is whatever that is, this is how the animation is going to play. Now if you want this to change a little bit, you can actually increase or decrease the values over here. And smoothing time is basically for your transition time. So how long it'll take to transition from one animation to the other. Generally I just leave it at 0. I've had no issues, honestly. Now in our animation blueprint, instead of this, we can use our walk run blend space. Alright, you can connect this blend space to the output. Now we would see that you have to provide the direction and speed, and doing that is actually pretty simple. So head into your event graph, and what you basically do is you grab your character reference over here, and from this we can actually get the velocity. So velocity, get velocity, and then from here we can get the vector length, so basically the magnitude of the vector. Alright, once we get that, for the direction, actually we have a node called calculate direction, which requires the velocity, and I will tell you what to do next. So we need direction and speed. So we can promote these to variable. So promote to variable, we can call this one direction, and we can call this one speed. And if the character is valid, we can set the direction and speed. Over here in the direction, for the velocity, we can just directly grab in this pin over here, and then what we can do is we can get actor rotation. Now if I hit compile and if I go ahead and plug these in over here in my blend space player, then in my transition over here, so walk run to idle, instead of not moving, what we can do is we can get the speed, and if it is less than a certain value, so if it is less than, let's say, about 10, so then we'll enter this transition. Similarly, if the speed is greater than 10, we'll enter this transition. So if the speed is greater than 10, so then we can go ahead and transition into the walk run state. So once we change that, we should have our logic working. So now if I go ahead and press play, as you can see, the walk run animations are working. So that's about it. Now we have finished animating the character with some basic animation blueprints. So that's all there is to it. Obviously, there are many more things you can do with this animation blueprint. Of course, you can have sprinting as well. So if you would have sprint, you would have another state called sprint, and then you would plug it in according to what logic you want. Basically, all you have to take care of is when your character can transition into states, and make sure it's not going to be in two states at the same time. That's about it. And in the event graph, anything that has to update, so for example, the speed of the character, those can be done over here on blueprint update animation event. So now I think this is more than enough for blueprints. And I think with this much of blueprint knowledge, you would be able to make an entire game. Assuming, of course, you would be ready to look into the documentation a bit and look into what the various functions do. If you actually play around with whatever we did, plus look at a few extra functions, you can create an entire game. And now, for the more keen ones out of you here, we are going to head into C++ now. We'll be taking a deep dive into the more advanced features of the engine. Now, not to worry for those people who don't know C++, I will also be brushing through some of the prerequisites that you need in C++ in order to get started. Honestly, there's not much to do with the language. Most of it would just be function calls and stuff like that. So anyways, without any more further delay, let's actually start learning C++ for Unreal. Now I will be going through the basics now. Now let's just talk a little bit about the prerequisite knowledge of C++ which you'll need to actually understand the further part of the course. I do still recommend you learn C++ separately, but I will get you guys what you need for Unreal, because it's really not that important to know the language. More so, you need to know the features which we actually will make use of in Unreal. So I'll just create an empty console application here. So it's just going to be a blank application with in the terminal. Now I won't even use this. I'll just use an empty project template. So I'll just search for empty in Visual Studio, of course. I mean, we have it right here. So just go click next. And doesn't really matter. I'll just look for a folder. So I'm just going to create it there and click create. So just leave all the settings at default. None of these would matter for now. Now once I've created this, I'll just go ahead and set up the basic stuff which you need for C++. So first of all, you'll need a C++ file with a main function in it. So just for my reference, I'm going to name it main.cpp. And we need a main function. We'll not get into that now. So int main, and we're just going to return 0. Now I'll not get into this, but the feature which first of all we'll need is to include code from other files. Now if you want to do that, you would do #include, and inside angular brackets or inside double quotes depending on the situation, you would include the actual header file. So let's say I have a header file, so I'll create one. So go ahead and call this, I don't know, header.h. Let's just leave it as this. And Pragma once basically means this header file will only be included once, so you won't have circular dependencies and stuff basically. But anyways, let's go ahead and type some code. So in order to create variables, that's the first thing you'll need apart from including. So including this header file is simple. So in double quotes you can put header.h, or you could even use angular brackets. Generally you would use that only for like standard C++ stuff, but both of them will work. So if you want to include header.h through this, you might have to add it in the include paths. So we'll not do that. We'll stick with this. So let's say something standard C++ such as IOStream. So I misspelled that. IOStream. I can go ahead and do this. Or if I have something standard C, for example, Windows .h, so I can do that. So for standard C++ libraries, you would not use .h. For standard C ones, you'll use .h. So for example, if you want CMath, that's going to be without a .h, or you could do math.h. This is the CMath library. So stuff like this. For now, we'll include header. So whoops. So header.h. Now this should work. And later on I will be showing you guys how to include Unreal headers. That's not an issue. So this main function I'd just like to go over. Basically your program is going to start from here. But again, as I told you guys, when you're developing a game in Unreal, you'd really not worry about the main function. That is handled in the engine. So if you actually go through the engine source, you will find somewhere where you have int main, and there'll be a while loop which actually runs the game. So we'll not talk about that. So let's write some code. So first of all, creating variables. And before we do that, one thing to note is that these are just text files. Honestly, you can put the same code in a header and a C++ file. It really doesn't matter. By putting .h, you just indicate that you want to include it as a header. So that's the only reason. Both of these are technically just text files and can be opened with any text editor such as Notepad, Notepad++, Visual Studio, or Visual Studio Code. Honestly, doesn't matter. So if you want to create a variable, you can first of all head into CPP reference to know the basic types. But if you want to create an integer, for example, you type in int space your variable name. So for example, we'll have my integer. And if you type in equals, you can assign an initial value to it. You actually don't need to do that. You can do this a bit later as well. But you have to do it inside of a function or something. So if I just put my integer equals 12 and make sure you end everything with a semicolon, this is not going to work because even though you have this line here, you're not executing this at all. So remember I told you guys the program starts from the main function. So over here, if I put my integer equals 12, this is going to work. Why this works is because we have included header.h. So it's as if it just copied over all of this content and pasted it in instead of this hash include. Now similarly, you can have other types which we discussed. So you can have float x for example, and you can have many other types. So for example, if you wanted a string, you would put in std string. In Unreal you use fstring, but again, now you're getting an error. That's simply because you have to include string. So these are the few additional complexities which come with C++. So std string, my string equals, let's say, test string. And you can go ahead and set the value again, test string. So not sure what we call that. So okay, my string is what we called it. So my string equals, and you can assign any value to it, or you could even use the constructor for this. Anyways, this is how you create variables like this. Data type, variable name equals value. Value need not be defined initialized as soon as you create the variable. You can do it later as well, but it's always a good practice to do it. Now one more thing is that these variables can be printed out which you will not use in Unreal. You'll use the print string function to print it on the viewport. But in a console application, you do something like std cout, and you would go ahead and print my string, for example. Again, we're not using this in Unreal, so that's the reason I'm not really covering this. So the error is because we haven't included the header which contains this function. So you can go ahead and include IO stream. And if you go ahead and run a debugger here, as you see, we get 232 printed because that was our string. Again, if we just delete this part, you would see we will get test string. And we can also print my integer like this. So we get 12. So this is how you would go about printing stuff. And what if you wanted to write your own function? So what if you have like 10 lines of code and you wanted it to be called once? So basically you can create a function with this syntax. So if you want to create a function, what you do is you'd put the return type. Let's say we create an addition function. So our result is going to be an integer. So the return type is int space your function name. So in our case, let's just descriptively name it add. And in the bracket, you would put the variables which you take from outside. So in order to add two numbers, we will need two numbers first of all. So we are going to pass two integers. So the same way in which you created a variable and in the same way in which you'd handle anything else, you would just do int a comma int b. So you separate arguments through a comma. So what this basically means is when I call add, so when I say add and I put my parentheses, so this is how you call a function. So if you want to execute add, this is how you do it, and you'd end it with a semicolon. Now inside the bracket, you would put the values of a and b. So in my case, if I just put in 12 and 43, or I'll just take some random numbers. Now the result of this is going to be returned here. And in fact, instead of, you can set it inside the variable. So if I do my integer equals add of 1342 comma 43, so whatever value will be returned here, that will be set inside my integer. Now if you want to actually write the logic for this, so you'd simply do return a plus b, something like this. So this is how you do a function. But honestly, you don't need the syntax, since we actually have a simpler way to actually write functions. We'll be using classes mostly, so you shouldn't really bother too much about all this. And with that being said, let me just show you guys how to create a class. So I'll do it in my header. So for example, I'll just do a class called student, and I'll open up my curly braces. Just follow along with the syntax, it's just a matter of getting used to it. So under private, so these were the private variables which we talked about in Blueprint as well. So I can say we have a name, and let's say we have his marks, so int marks, something simple like that. And under the public section, we can have some methods. So we can say std string, and we can call this one get name. And instead of writing the definition over here like this, so this is similar to what we did here, it's just that it is inside the class now. What we can do is we can only have the declaration here like this, so only the name is given here, but we can actually have it defined outside this class itself. So I can do this, and I can go ahead and actually make another function. So I can say int get marks. So now you can also go ahead and define this outside the class. How you do that is you'd use this syntax. I'm not talking in depth about this, mostly because there's a shortcut to do it, which I will talk about. So std string, and what was our class called? Student, followed by two colons. You do get name, and you can write your function definition over here. So you can go ahead and return, I guess it was called name, so name. And similarly, you can provide a definition for the marks as well. So int student get marks, and you can go ahead and write the definition for it, return marks. So basically, you are going to get the marks from this. Now, if you want to instantiate a student, so let's say you wanted to create a student object from this. Remember, we talked about classes and objects. So you just do student, let's just call him S1 for example. And you can do S1 dot get name. Now dot is what you'd use to refer to the members inside a class. In Unreal though, when you create objects, you generally have a pointer to it. So basically the memory address of it is a pointer. Nothing much to worry really. So I'll just show you guys a way to create it. So if I type in student pointer instead equals new S1. Basically we are dynamic new student. So new student. Basically we are dynamically creating this, and instead of the actual variable name we have a pointer to it pretty much. Now nothing much to worry about. You just put a star instead of just referring to student. And if you want to refer to something through a pointer, you do S1 instead of putting a dot. Now if you were to do dot, you see it just got replaced with an arrow. So you'd refer it with an arrow. So something like this. So if we actually just create a method to set the marks. So I'll just do void set marks, and it's going to be int, the parameter which we need. So int marks. So we'll take this value from outside, and we can say marks. Okay, we are using this again, so we can type in marks with a lowercase. So marks equals marks. So what we can do is we can say S1 dot set marks, or rather with the arrow set marks, and we can just say 56 for example, just a random number, and we can print it by typing in stdcout, and we can print this. So run a debugger. And as you can see, we got 56 printed, so we successfully set the marks. So this is how you would call functions which are defined inside a class, and you will need to call them through an object because you need to instantiate them first of all. This is something which you will not do in Unreal. You would use the functions such as spawn actor and stuff in order to actually create objects. But anyways, this was just something I showed you guys. Now with this much you can pretty much do it. If there's anything else such as for loops and stuff, you can just follow along and look at the syntax. That's pretty much it. And if statements are also easy, so you just do if, and you would have the condition in the bracket. So let's say the marks is greater than 56, so I can do S1 get marks. S1 get marks greater than, let's say, 35. Then we can go ahead and print that the student has passed. So stdcout, and I can say passed. So if I do this, as you would see, we get 56 and passed. Obviously this is not in a new line, but that's pretty easy to do. So you can do stdendl, and now you'd see 56 passed. So with this much basic C++, you can actually follow along, but again I do recommend you separately learn a bit of C++ before you come in. The upcoming sections of this course is going to be for intermediate and advanced users. So before you actually get started, I recommend you guys do a few things. First of all, spend maybe a few days actually exploring the engine a little bit more, maybe creating a tiny game or something. And secondly, make sure you do know the basics of object-oriented programming in C++. So stuff like your classes and stuff like structs, functions and variables, and the basic stuff basically. If you guys are familiar with that much of C++, and you have used the engine a little bit, you would be able to follow along with the further part of the course. So in order to start coding in C++ for Unreal, head into Tools and open your Visual Studio project by clicking on that button over there. And you should be in some sort of a file over here. Now you may have something blank, so we'll just close that. Now under your games folder, you should see your project name here, and this is where you actually start working with stuff. Now we don't have anything actually under this. We are going to be having our source files. So you don't actually create it here in Unreal. In Unreal, you actually have the option to just generate all the boilerplate code for you. You can do that by heading into Tools and by typing in New C++ class. Now over here, you get various options. Now if you have something really simple, if you have some pure C++ logic, you could just create an empty class and you could just tinker around. It's just going to create a constructor, destructor, and it's going to write the class definition for you along with no macros, just the standard C++ one. But the most basic useful thing that you'll use in Unreal is going to be your object. So under all classes, if you select object, this is going to be equivalent to your object in Blueprints. However, when you actually create it, so if I just create it, just select public, and this is just to determine where your CPP file will be, whether it will be in the public folder or the private folder. Now over here we can just call this CPP object. So let's not confuse ourselves. Let's just call it CPP underscore, yeah, object is fine. So this is not an object, this is the class which is named CPP object. Please don't get confused with that. So create a class, and now as you can see, you have some really basic code. And one thing you might have noticed is, okay, live coding is on, that's a different story. But what you might notice is it already has several things, such as it has included some header files here. These are just Unreal standard header files, and you will need them. And you might have seen a few extra macros as well. So this is a U class macro, and inside these actually take in arguments too. Now these are useful for the Unreal header tool. Basically when you compile this, it happens in two phases. Basically your Unreal header tool sets up stuff which are specific to your objects for Unreal called U objects. And in order to implement those features, it does certain extra steps. So when you get a compiler error, it could be either from that or from your standard C++ compiler. Anyways, that shouldn't be much of a problem to you guys. Now, if you might have noticed, even though we called it CPP object, it's prefixed with a U, and we have inherited it from U object. Now, why is it like this? Now, basically any object that you create, that is a derived class of U object, must have the prefix U, and even object has the prefix U. In Blueprint, it is just shown as object. However, in theory, it is actually U object. And similarly for actors, so let's actually create an actor as well. So we can head back into the editor, tools, new C++ class, and as you can see, you see pretty much the same stuff over here. But these are the two important ones, object and actor. Now obviously character, pawn and stuff like that are important, but they don't have any specific prefixes. So I'll be talking about them a bit later. And obviously we'll talk in depth about the inheritance hierarchy. So I'll select actor. And let's call this one CPP underscore actor. Create that. And live coding, if it works properly, it should in theory compile it for us. Now if we actually open it up and reload this, you would see you find something which looks a little bit overwhelming if you're looking at it from the first time. But if you ignore this macro and if you ignore this comment here, I don't even know why this comment exists, because if you come to an extent where you can write or interpret this code, I don't think you need to know that a constructor sets the default value. So we'll just delete that comment. And begin play is basically your event begin play in Blueprint. Same thing. Tick is again your tick in Blueprint. You can delete the comment.